Okay, students, we're going to just go through number 35 out of your textbook in chapter 12. And I'm going to have to write down some of the data. So let me do that real quick. You're just looking at your numbers. And what I did, just FYI, is I just converted those to decimal instead of the scientific notation. Okay, so those are the same values as those rates, but in a decimal form. Okay, so let's compare. We have trial 1, 2, 3, 4. It's not listed that way. Let's compare trials 1 to 2. Now, if you're looking closely at trials 1 to 2, the iodide went from 0.12 to 0.060. And if you plug that in, that's 0.5, or it went down by half. But that's okay because the rate went down by a half. So remember, I asked you not to get too attached at the doubling business, because if the concentration of iodide goes down by a half and the rate goes down by a half, then it's first order. And then, of course, that's because we can cross out the OCl minus because it is constant there. So with respect to I minus, this is first order. Now, if you don't like that half business, that's okay, because you could think of it this way too, that from run 2 to 1, that's doubling. And then from 2 to 1 in the rate, that's doubling. Okay, so right now what we have is our rate equals K times iodide to the first order, OCl minus, we don't know, and we'll call it N. Okay, now here's where this one was, and I can understand why you asked me, which is good, and that's why I signed it, is for us to think about what's happening with the OCl minus. Like, we need runs the way we've been setting them up, where iodide is the same, but none of them are, right? Iodide, they're all different. And so how are we going to find the order with respect to OCl minus? Well, this is an example of where we should probably use our long route, because I will need to do some plugging in. We do know, right? We know the order for I minus, so this is going to help us. So I'm going to compare runs 2 and 3. And the reason I'm going to do that is because OCl minus is changing there. And so we need the runs where that's changing if we're going to find its order. Okay, so let me show you what we'll do. We're going to compare rate 2 to 3. So rate 2 will equal K times I minus to the first order and the concentration in that run, OCl minus in the concentration in that run, but we don't know. And we're going to compare it to rate 3, concentration in run 3, OCl minus concentration in run 3. Okay, now what can cancel out here are the K's. Those are the same. And now let me plug in some numbers. Rate 2 is 0.0395. Rate 3 is 0.00988. The concentration of iodide in run 2 is 0.060. But we know that that guy is to the first order. So that's not unknown. And in run 3, it's 0.030 molar. And then OCl minus in run 2 is 0.18. But we don't know its order. And in the third run, it's 0.090. Okay, so take a minute and think about what we're looking at here. I think in this case, it's really going to help us to kind of simplify some of these numbers. So 0.0395 divided by 0.00988 is 4. So this mess is 4. 4 equals, and then 0.06 to the first is just 0.060, right? And 0.030 to the first is just the same number. So this is equal to 2, correct? So now we're going to try to isolate the n. So I'm going to divide the 4 by 2, correct? So 2 is going to equal 0.18 to the n over 0.090 to the n. And then remember, to get these out of there, I'm going to say log of 2 equals n log of 0.18 divided by 0.090. That is also 2, correct? 0.18 divided by that. So n will equal log of 2 over log of 2. So n equals 1. So this one is a good one because it shows us that if we know one of the orders, we can solve for the other one, even if the other one doesn't have runs where that concentration was kept constant. Okay, so what I'm recommending you guys do now is to do number 37 in the homework. Number 37, we'll see if you reinforces it. The only difference there is that it's in micromolar. And so there's 10 to the 6 micromolar in 1 molar. Don't worry so much about the units, though, because you're really just looking at the relationships there, just the same way. And the only reason they're using micromolar in number 37 is just to make the numbers more manageable. So overall here, to kind of wrap up, rate equals K, I to the first order, OCl minus to the first order. Now you can go ahead and solve for K like we practiced. K will equal rate over those. And then now you can solve for that. I won't go through that, but you can now take that over. You can pick any run that you want.